Hello all. Today we are solving LeetCode problem number 2075, decode the slanted ciphertext. So a string named original text is encoded using a slanted transposition cipher to a string named encoded text with the help of matrix having a fixed number of rows actually. So what exactly this means is we are given a fixed number of rows named rows as the input and original text which is encoded using a slanted transposition cipher actually. So which means original text is placed in top left bottom right manner. So we can understand by looking into this this particular example actually. So here you can see that the text is being placed in diagonal way, so which is top left bottom right manner. So we place the first letter here, then followed by the next character here, and we place again, so it goes on based on the diagonal way. So to understand this clearly, if you are looking into this particular example, we have this original text named cipher, so which is placed, the first C is placed in this diagonal, and the next word which is I is placed in the next one, and P is here. And then when this limit is done, which means the row is completed, we move to the next possible diagonal. So we start from top left and we go diagonally, and then again we come to the next set of diagonal, and we move in this pattern of placing these words and creating this uh, slanted transpositions cipher. So what we have to do is so the encoded text is formed by appending all the characters of the matrix in a row wise fashion. So we have to decode the text and then we have to return the output. So basically, looking on the example part, you will be given an input named encoded text, and this with the spacing actually. So we have given based on the cipher the transposition cipher, slanted transposition cipher, we are getting this particular text and we are given the rows actually. So we have to decode and we have to return the actual text. So looking at this particular problem, this is the explanation and the hint which is being given. So what we can do is use this cipher in encoded text. What we can do is we can place it in the matrix actually. So we are given rows and we are giving encoded text actually. So to find a column, we can divide the length of this, and which will be divided by, length of encoded divided by rows, you will get the columns value. So based on that, you can create a matrix. Maybe it can be m cross n, so you can create m columns and n rows. So based on that, you can create and you can place the values actually. So you can iterate through this encoded text and you will be getting the index position, right? So for example, here we are having this will be 1 2 3 4 5 6 7 8 9. So this is 9 for example, and we are forming this particular matrix, right? So and rows is given as 3. So what we can do is to locate this I, we can locate this I, or we can place everything actually. So we have CH, right? So we are placing CH and CH, and then there comes I, so we place I here and E here. Okay, so okay, this should be 4. Oh, then maybe based on the spacing, I'm not sure how much the length is. I guess this should be somewhere around 4, so which means we are getting rows as columns as 4. So I and PR, so we are placing in this particular manner based on the spacing. So here we are having 2 spacing, right? So that is why we are, or not here 2 and 3, so 3 spacing. So this is how we are placing it basically. So we process left to right, and down, left to right, down, left to right. So diagonally it's how we are processing this particular text actually. So based on that, we can place in the matrix and iterate the column. So which means you process this one first and this one first, and then you move to uh, the next diagonal part and followed by next diagonal part, right? So that is how you will be processing. uh, Oh, I'm so sorry about this, because you have CIPHER, so which means you will process the same way diagonally. So you process this and you come to the next diagonal, and you come to the next diagonal and process it, and when this is done, you move to the next set of diagonals. So I iterate and process by diagonal. So finish one diagonal or one set of diagonal actually, and then you can move to next set, right? So you can iterate the encoded text. So basically I iterate the encoded text and then place it in the diagonal. So I think I haven't write it down cleanly. So steps, uh, iterate encoded text, place them in diagonal, in matrix, process diagonal. So just remember these three steps. So this is how we can use it, and we can process it, and then we can decode the particular text actually. So this is a simple way. Or there is one more very simple way, is you can locate the index actually. So because you are given the value as this is ch, then you have space and ie and some space and pr, right? So which means you have some spaces here, and based on that this will be 0 1 2 3 4 or something like this, right? So based on this particular matrix, this should be 3 spaces, and then you have 4 here, and this position is 5. So if you find the index position as 5, you can locate the I here, and then what you can do is you can add it or append it into the string or empty string or array, whatever you want, right? So that is how you can decode it. So to locate this, so first one is we start with C, we add the C into this actually. So then what happened is we have to find the next index, which is because based on this actually, so this is the first position and this is the next diagonal position. The fifth index indicates the diagonal next position, and based on this P is maybe, I think it should be again added with the 5, so which means 10. So 6 7 8 9 10. So 0 5 10, then this will be 1 6 and 11. So based on this index position, you will place or append into the empty string. So instead of iterating through the matrix, you can iterate through just the characters, the encoded text, and you can find the index position and then you can place it. So to find the index position, how do we do this actually? So this position is 1 1. So where you have 0 0 as the initial position, and the next one is 1 1 and 2 2, right? So we can use this to somehow infer the index. So how do we do this? You have I is equal to 1 and j is equal to 1. So one specific observation here is you are at column 2. So if it is a 0 based column, you are at column 1, so that's why j is equal to 1. So to get 5, you can add I plus j is equal to 2, and you are missing 3 more things actually. So how do we get that? So that is nothing but you can add the column with the row basically. So you are at 1 here, so that is j, that is a column. So at 1, which is 1, and you have columns, so which is nothing but 3, right? So for this problem it is 3. So based on this you get 3 here, so adding these two you get 5. So this is the equation which we are going to use to find the index. So I plus j plus m cross j, so using which we can find the index. So this is the main observation here, so with which we are going to solve this particular problem. And time complexity for this is we will use columns and row for locating this actually. So this will take big O of m and n, which is m means column and n is the given row, or let this be row, right? So that is it. With this observation, let us go ahead and code. So we start with the base case, so which is if rows is less than or equal to 1, return encoded text. Okay, oops, maybe we can copy it. Yeah, return encoded text, and then we have to find decoded, be the empty string. So now this is done. Okay, so now length is equal to length of encoded text, right? And the next one is you have to find the columns. Columns is equal to n divided by rows. So now we are iterating. So for I in range times columns, and for j in range times this is rows, right? And index is equal to I plus j times columns. Oops, yeah. So now this is done. So now we have to check if the index is out of range. So which is if index is less than rows times columns, then only it is valid, and we will add it to the decoded. So what happens here is, so we will add plus or equal to, we add the encoded text actually. So encoded text of index, so that will be added to this. So yes, yeah. So now this is done. We have to return by removing the spaces actually. So in the right you will have spaces, so that you have to strip it down. So we will be using our strip function. So decoder dot r strip, yes. So that is it. Let us run it and submit it, and there you go. Thank you.